This is the question that has came in GATE 2023 from Computer Organization and Architecture from the pipeline part. Okay. So let us first read the question properly. What has been mentioned that consider a three-stage pipelined processor. Okay. So there are, this is the stage 1, this is the stage 2, and then this is a stage 3. There are three-stage pipeline processor having a delay of 10 nanosecond. Whenever any instruction comes here to execute, it takes 10 nanoseconds. This stage takes 20 nanosecond and this stage takes 14 nanosecond. Assume that there is no other delay and the processor does not suffer from any pipeline hazards. Also assume that one instruction is fetched every cycle. The total execution time for executing 100 instructions on this processor is. So no, we know that because here you can see the delay is not uniform, right? So whenever we have to calculate how much time each instruction will take, so we should know how much time the instruction will take to execute in the terms of number of cycles. So whenever the first instruction will come, it will take one cycle on this stage, and when this first instruction will go here, the second instruction will arrive here, right? So the first instruction will take one cycle, two cycle, and three cycles to complete, right? Means here we know that the total number of stages are 3. Let K denotes the number of stages. So the first instruction will take 3 cycles, but the remaining instructions that will come whenever the I1 is here, the I2 will come here. When the I1 will come here, the I2 will come here. And when the I3 will complete its execution, the I2 will be on the final stage. So only the first instruction will take the 3 cycles, but the remaining instruction will take only one cycle, right? So first we should calculate what will be the cycle time. So let us denote it with the TP. TP is the cycle time. We know that when the stage delay is not uniform, then what you have to do? You have to take the max of the stage delays. What it is? 10, 20 and 14. So what is the maximum among them? It is 20. So the cycle time will be 20 nanosecond. Now you have to calculate the total execution time. So total execution time is equal to the first instruction will take k cycles. How many instructions are there total? Suppose there are total n instructions. So the first instruction take k cycles and the remaining n minus 1 instruction will just take only one cycle. It means n minus 1. The first instruction will take k cycles and the remaining n minus 1 instruction will take just one cycle. So these are the total number of cycles will be required if there is k stage pipeline and total number of instructions are n. So these are the total number of cycles and each cycle time is TP. So this is the formula that we will use. Here k is 3 plus n is the number of instruction is 100 minus 1 into the cycle time, which is 20. So what it will be? 100 minus 1, 99 plus 3, 102 into 20. So what it will come out to be? It will be 2040 nanoseconds. 2040 nanosecond. So this will be the total time that will be required for the execution of 100 instructions. So the answer will be 2040. Okay. I hope now this question is clear to all of you. This is the next question that has came in GATE 2023 from Computer Organization Architecture. This is a very nice question If you have a good understanding to understand each of the assembly code, each of the line of the assembly code, if you will understand each and every line of the code, it will be very easy for all of you to understand and give the answer of this question. Let us read the question properly. Consider the given C code. This is the C language code is given and its corresponding assembly code. The corresponding assembly code of this C language is this part. With a few operands, U1, U2, U3, U4 are the 4 operands being unknown. Some useful information as well as the semantics of each unique assembly instruction is annotated as inline comments in the code. The memory is byte addressable. Always focus on the keywords. The memory is byte addressable. Which one of the following option is a correct replacement for operands in the position U1, U2, U3, U4? You can see U1 has used here, U2 has used here, U3 has used here. So at a different place, different operands have been used. U4 have been used here. And you have to tell the value of these operands. So first let us see the C code. What it is doing. There are two arrays, A and B. The loop has been executed and each value of array of B is multiplied by 8 and then stored in the array A. So this functionality has to be performed and we will see the corresponding code in the assembly language. Okay. So let us see here what it is doing. It is initializing. It is saying R1 to R5 are 32-bit integer registers. Okay. It is initializing as R1 equal to 0. It is taking R1 as a register. It is initializing its value to be 0 and R2 is 10. So why it is using these values, you can see it will execute the loop. R1 will be initially 0. After executing one time the loop, R1 will be incremented to 1, then 2 and it will go on up to 10. For example, you can see here the first line, what it is saying, jump if equal. If R1 is equal to R2, then jump to end, means end the loop. End means this line 9. If R1 is equal to R2, then end the loop. So when R1 will be equal to R2, when R1 value will go to 10. So after every execution of the loop, the R1 value will be incremented and after executing 10 times the loop, the R1 value will become 10 and then loop will end. This is the meaning of this first line, line 01. Okay. Focus on one more thing. R3 and R4 is initialized with the base address of A and B. Means the base address of array A is stored in R3 and the base address of B is stored in R4. Okay. Now let's see the line number 2. What it is saying? It is saying that we have to load the data from memory of R4 plus 0. Right? Means R4 is storing the address of B. Right? And we have to take the value of R4 plus 0 means, suppose this is an array B indexing 0. So how you will access the index 0? You will access by B plus 0, right? And B value is stored in R4. So R4 plus 0 means we are accessing the value of B0. So B0 value is stored in R5. Okay. Now B0, this value we have taken in the register R5. Now what we have to do? We have to multiply it with 8 and then we have to store it in A of 0. Now just see the next statement. What it is doing? It is performing the left shift. R5 left shift U1. Now we should know the value of U1. So to multiply the R5 value with 8, what it is doing? R5 is performing left shift U1 number of times and then storing the value in R5. So for example, suppose we have a binary number 10. What is its decimal value? It is 2. Suppose we perform 10 left shift 1. What is the meaning? Means this 1 will shift left side. So what will happen? It will become 100 and now what it is value? It is, this is value 4 Now suppose again if we perform left shift on this value 1 times, then what will it will become? 1000. It means 8. Means whenever we perform 1 times the left shift operation, the value will be multiplied by 2. Again it will be multiplied. Again if you perform the left shift, again it will be multiplied by 2. Again if you will perform the left shift, again it will be multiplied by 2. So if we have to multiply the value by 8, we have to perform the left shift 3 times. So that's why the u1 value will be equal to 3. It means the R5 will be left shift done 3 times. So U1 value will be 3. So from the option, the A option and C option will be eliminated because only in option B and D the U1 value is 3. Okay. So now the R5 value is multiplied with 8 and stored again in the R5. Now what is the line 4 it is doing? It is storing the R5 value in R3 plus 0. R3 plus 0 means R3 is storing the base address of A. So in A of 0 we are storing the R5 value. Means R5 is storing the 8 times the multiplication of R4 plus 0 and then it is stored in R3 plus 0. Okay. So now the first loop has been executed. The value has been stored in A of 0. Now we have to increment. So now what it is doing is R3 has to be incremented, na? Because what it was doing R3 plus 0. So first it was pointing at this location. Now it has to move to this location. What type of value it is storing? It is storing integer value, right? Now if you have to shift to the next location, the integer value is how many bits? 32 bits. 32 bits means 4 bytes, right? And it has been mentioned that the memory is byte addressable. So if the memory is byte addressable, then we have to shift this location by R3 value has to be incremented by 4 because it is byte addressable and the integer is of 4 bytes. So R3 value will be incremented by 4. Similarly, R4 value will also be incremented by 4. It means the U2 value, this is U3. So U2 value will also increment by 4 and U3 value will be also 4. Okay, because R3 has to increment by 4, R4 has to also increment by 4 because the integer is of 32 bits means 4 bytes and the memory is byte addressable. If the memory was word addressable, then the U2 and U3 value will be 1. But because it is byte addressable, that's why the U2 and U3 value will be 4. Okay. So if you see the option B will be correct. U2 is also 4 and U3 is also 4. Now if you see the line number 8, after performing the first loop, again it will check the condition whether the R1 value is equal to R2 or not. Here you can see the R1 value has been incremented by 1, right? The R1 value has been incremented by 1. So now the R1 value is 1. And again it will check the condition whether it is true or not, right? So U4 means jump to L01. Okay, so that's why option B will be correct. Okay, I hope the complete solution of this question is clear to all of you. From computer organization architecture that has came in GATE 2023. Okay, so let us read the question properly. A 4 KB byte addressable memory is realized using 4 1 KB memory blocks, right? So this is the first 1 KB memory block. This is the second 1 KB memory block, the third 1 KB memory block, and this is another 1 KB memory block. So these are 4 1 KB memory blocks. 2 input address lines IA4 and IA3. You can see here IA4, IA3 are connected to the chip select port of these memory blocks through a decoder as shown in the figure. This is a decoder. The remaining 10 input address lines from IA11 to IA0 are connected to the address port of these blocks. The chip select is active high. Okay. The input memory address IA11 to IA0 in decimal for the starting location of each block x1, x2, x3, x4 are among the options given below. It is asking that this is the first block. The first block The base address is x1. The starting address of this block is x1. The starting address of this block is x2. The starting address of this block is x3, and the starting address of this block is x4. And it is asking the value of these blocks when all these lines IA11, IA10, IA9, 8, 7, 6, 5, 2, 1, 0, the value of all these input is 0. Now, first thing that you should understand is what is decoder. What is the work of decoder? Let us draw this. This is a decoder. There are two input lines. One is IA4, the other is IA3. Four outputs. Q0, Q1, Q2 and Q3. Let us write IA4 and IA3. So what are the possible values these two can take? 0, 0. So when both the values are 0, it means 0. It means this Q0 will be 1 and all other will be 0. When it will be 0, 1, it means the Q1 will be activated, Q1 will be 1 and the remaining will be zeros. When it will be 1, 0, then Q2 will be activated, Q2 will be 1 and the remaining will be zeros. And when it will be 1, 1, then it means 3. It means Q3 will be activated, Q3 will be 1 and the remaining other will be zeros. Okay. So let us write all the input lines. The input line is from 0 to 11. So let us write it down. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. 0 to 11, these are the input lines, right? All these values have been given to be initially 0. Only A4 and A3 has to be changed, right? So let's change the color. So initially, these values are zeros. Only 4 and 3 can change. So we have four possible values of 4 and 3. One is 0, 0, the other is 0, 1, the other is 1, 0 and the other is 1, 1. Let us complete it. So this will be the address of the first memory block. This will be the address of second memory block. Similarly, this will be the base address of third memory block and this will be the base address of fourth memory block. So what is its value? If you see all the zeros, it means its value is 0. Now what is the value of this second? You can see it is how you convert a binary to decimal. You multiply this value with 2 to the power 0, then 2 to the power 1, then 2 to the power 2, then 2 to the power 3, right? So it is 8. Similarly, if you see here 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So it will be 16 and it is 16 plus 8, it is 24. So the base address of the different blocks are 0, 8, 16 and 24. The base address of this will be 0, this will be 8, this will be 16 and this will be 24. So the correct answer is option C. I hope the solution is clear to all of you.